find the inverse transform of 1 over s squared plus 6s plus 13, the first thing you have to do is to complete the square. So let's see, s squared plus 6s plus 13. The way you complete the square is first take the middle number, the coefficient of s, and take half of it. Half of 6 is 3, and that goes inside the square. Then you have to figure out what should be added afterwards so that these two are equal. 3 squared is 9. 9 plus what gives you 13? Well, obviously 4. 9 plus 4 gives you 13, right? And if you actually expanded this by rewriting this as s plus 3 times s plus 3 and foiling out, you'll see that both sides are equal. And then you can rewrite 4 as 2 squared. And this tells us that the answer for this would be 3 and then 2. Now, it's a little cryptic here what it means. In the second question, f bar s plus 3 really means s plus 3 is plugged into this f. So this is just another way of writing this. And it's asking for what f of s would be if f of s plus 3 is 1 over s squared plus 6s plus 13. But because this thing, we know it to be this one, the current question is, if I know that f of s plus 3 is s plus 3 squared plus 2 squared, what is f of s? That's the question. Well, here's how you figure it out. First, identify s plus 3 in both cases, and empty that. Okay. So you know that it's this function where you plug in s plus 3 on the left and s plus 3 here so that they're equal, right? But now, because we're trying to look for f of s, you put s here, you put s here, and that's it. So the answer for this would be 1 divided by s squared plus 2 squared. And now, in order to finish this, you need two formulas. One is that Laplace transform of sine AT, or let's call it BT because I want to use A later. So sine BT is B over S squared plus B squared. And you can find this formula in any Laplace table. And for our specific case, because you have this 2 in here, we should think of Laplace transform of sine 2t equals to 2 over s squared plus 2 squared. We'll worry about this 2 later, but I want you to see that right now the bigger problem is this is for s squared plus 2 squared, and I actually want to know how to invert this function, this one right here. So how do you invert this? Well, recognize that instead of this s here, you have s plus 3 residing there. So there's another formula that says the following. If you have Laplace transform of e to the at of some function t, then that's same as Laplace transform of f, which we use the capital F for. But instead of f of s, we put s minus a. Okay. So in here, the definition of f of s means it's the Laplace transform of just f of t without anything in it. Okay. So if I put these two together, we have an interesting formula which says that if I have a Laplace transform of e to the at sine 2t, let me try a different color just so that it's easier to see. All right, so let me try a different color. Okay, so these two together will tell you that Laplace transform of e to the at times sine 2t is equal to 2 over s minus a squared plus 2 squared. Because this formula right here says if e to at is multiplied, instead of the regular s, you have to replace s by s minus a. And that's exactly what I did. This s got replaced by s minus a, right? And for our specific purposes where I need exactly s plus 3, you would get s plus 3 if a was negative 3, right? If a is negative 3, then plugging in negative 3 into a, you get s minus negative 3, which is s plus 3. So you need negative 3 here, negative 3 here. And we're almost there. So we know that Laplace transform of e to the negative 3t of sine 2t gives you 2 over s plus 3 squared plus 2 squared, which is almost the answer, except that we still have this 2, whereas what we want is 1. So we have to get rid of this 2, and you can simply do that by dividing both sides by 2. And that's possible because Laplace transform is linear. So if I put a 1/2 in front, that 1/2 and 2 will cancel, and you'll just get 1, which is exactly this. So in this case, the answer would be simply 1/2 e to the negative 3t sine 2t. And in WeBWork, you can certainly rewrite this as like exp for exponential functions, negative 3 times t sine of 2t, and then you can divide everything by 2.